I have 2 amino, 1 butanol. This is the skeletal diagram. We have CH3 here. The electron geometry for oxygen is tetrahedral because it has 2 lone pairs and 2 bonds. The molecular geometry is bent because it has 2 lone pairs, and the hybridization is sp3. Next, there's a C here, and the electron geometry is tetrahedral. This is 109.5. 109.5. The molecular geometry is the same since it does not have any lone pairs. And the hybridization is sp3. Next, the C, the carbon here has an electron geometry that is tetrahedral again. The molecular geometry is the same, and the hybridization is sp3. The carbon here again has the same electron geometry. It's tetrahedral. 109.5. Molecular geometry tetrahedral, and hybridization is sp3. Similarly, the carbon here has an electron geometry that is tetrahedral, 109.5, and molecular geometry tetrahedral, and hybridization sp3. The nitrogen has an electrogeometry that is tetrahedral since it has 1 lone pair and 2 hydrogens. All the carbons had 4 bonds. That's the reason why they were tetrahedral. Molecular geometry of nitrogen is trigonal. Pyramidal. and the hybridization is sp3. It's trigonopyramidal because it has one lone pair. Question 2. A constitutional isomer is when there's the same formula but different names due to the different locations of the branches. This is one of the isomers. First, let's name the chain. The parent is bute, since it has single carbon hydrogen bonds, it's alkane. And the locant, we have 1 and 4. Since 1 is the lowest, we take 1 into consideration, and the branches, we have 1 branch, so it's 1 bromo. We have 1 branch, but the locant, that is the location, is 1, not 1 bromo. So since it's locant, prefix, parent suffix, the locant will be first, and the parent suffix will be at the end. The second constitutional isomer looks like this. Let us name the parent. First, let's name it from this way, and name it from the other side. We have 3, so it's prop and single carbon hydrogen bond, so it's ane. The locant, we have 2 locations, that is 1 and 2 and 2 and 3. We take 1 and 2 into consideration. We have 2 branches, that is 1 and 2. Branch number 1, we have bromo, and branch number 2, we have methyl. Since we're supposed to go alphabetical order. The Bobo will be first. Next, the metal, and then the parent suffix. This is the locate prefix, and this is the parent suffix. Our third isomer is this, with the Bobo attached in between. Then let us write the numbers 1, 2, 3, 4, and the other side 1, 2, 3, 4. The parent is bute, that's single carbon hydrogen bond, so ane. The locant, we have 1, we have 3 and 2. Since we consider the lowest, we use 2, and branches we have Bobo, which is attached to 2. Since it's locant prefix, it'll be 2 Bobo, and our parent suffix butane. The fourth isomer is the complex isomer, which has a cycle and a bromine attached to it. We need to choose the longest chain or the longest cycle. So here we have 1 and 2, we have 4 and 2. Since the cycle is the longest, we choose it becomes the parent. Therefore, it's cyclobute. Again, single carbon hydrogen bond, so ane. And the locant, we have 1. So it's 1, and the branches, which is Bobo, at 1. Therefore, 1 Bobo cyclobutane. Number 3, we have phenyl and we have cyclohexanol. Let's draw these. So we have phenyl, and cyclohexanol. When both lose a hydrogen, we see that phenyl is more stable, whereas cyclohexanol is not as stable as phenyl. The reason is due to resonance. Phenyl is more stable. This is due to the spread of the negative charge onto the ring. But cyclohexanol does not have any resonance structures as any resonance to do, so there's no spread of charge. Therefore, it's not as stable.